From the perspective of speed and responsiveness of automation, the process industry's packaging, paper, plastics, and textile manufacturing applications are among the most challenging. Conveyors, continuous sheets, and webs are moving faster than ever, even as the volume of real-time data needed to feed industry's digital transformation ambitions continues to mount. So, how can a maker of industrial networks and I/O systems that make all this happen continue to keep pace with the mounting demands of end users and machine builders? Well, we're here today to find out. Hi, this is Keith Larson, editor of Control Magazine and ControlGlobal.com. And welcome to this Solution Spotlight episode of our Control Amplified podcast, today sponsored by WAGO. With me today to talk about the pressures to perform that these trends place on automation suppliers is Charlie Norz, product manager for I/O systems with WAGO USA. Welcome, Charlie. A real pleasure to chat with you today.
Hi, Keith. Yeah, thanks for this opportunity. I'm glad to be here.
Yeah, it's a real pleasure. We go way back, probably further back than I'd care to acknowledge to most of our listeners. So it's a real pleasure to chat.
It's been a while.
Enough of that. But over the past several years, just the last few, more and more machine I/O has been migrating out of the protection of control enclosures and onto machines themselves, really closer to the action and the tough conditions that often entails. What technologies and product features do you see have made this migration possible, and what are the benefits to be gained by both machine builders and end users?
Yeah, I would say that the migration of I/O from the control panel to the machine has been made possible by networking technologies that can both reduce the cost of distributed I/O while increasing system performance. So things like Ethernet-based distributed I/O is one factor, and with the high rate of adoption of Ethernet, the hardware is very economical. These devices also offer low latency of data that is required for more and more applications, as you mentioned. And also, we have seen that like I/O Link is becoming more accepted for sensors and actuators and many other industrial components. And the benefits of I/O Link include high performance with the bonus of device health data that can be used to increase productivity. In this age of digitalization, end users are implementing strategies to take advantage of device data to help them with increased production rates while reducing downtime and, of course, increasing quality.
Yeah, that makes a lot of sense. Everybody's looking for more ways to diagnose potential problems and head things off before they become real headaches, aren't they?
Yeah, it's the name of the game, right, of increasing uptime.
Absolutely. Your I/O system field, or WAGO's I/O system field, also features Bluetooth connectivity, which I think yours is among the first I/O modules to include that, but it's obviously another one of those up-and-coming technologies similar to I/O Link. What new possibilities does Bluetooth bring to the party for you?
Well, yeah, I think that Bluetooth is very interesting. Obviously, everybody's used to using mobile applications in their daily lives, but remote devices like sensors and actuators are becoming smarter all the time. And using technologies like I/O Link, instruments now provide a wealth of information in real time about what it's measuring as well as about itself. So this also means that these devices are becoming more complex, requiring configuration during commissioning. So we've added Bluetooth to our IP67 rated distributed devices so that technicians and engineers can stand in line of sight of the I/O block and the sensor while using their cell phone or tablet to configure the device or to monitor the data in real time. So this is much more convenient than trying to commission a device over a wired network from an engineering station a few rooms away. And we see that using a mobile app to configure or monitor real-time data helps speed commissioning and troubleshooting.
Yeah, it makes sense too, because if you have to tap into some connections that are hardwired, it kind of defeats the IP67 purpose if you happen to be in a running environment, doesn't it?
Yeah, I mean, I think that being able to communicate over networks is a big plus, right? So you can be in a single room and see what's going on in your plant floor. But when you have to get out there and configure a particular sensor, right, it's much easier to do standing in front of it. And why not do it with a mobile app to help you with that configuration?
Yeah, that makes a lot of sense. Another key aspect of I/O system flexibility is in the variety of options available for connecting to field devices. there any significant usage trends among the device connectivity options preferred by users, machine builders? You mentioned IO Link. Any other aspects of that?
Yeah, well, I would say that, no surprise that traditional industrial field buses like Ethernet IP and Profinet are most commonly used for distributed I/O. Mm-hmm. However, we are seeing more users moving to OPC UA and MQTT for SCADA and even cloud-based applications. These two protocols offer benefits for IoT applications and are becoming the de facto standard for plant floor to enterprise connections. So I'm saying that, we're seeing users use a lot of traditional field bus, but they're also converging with that IT layer and using things like OPC UA.
Mm-hmm. So that's kind of consistent with the more open architecture concept of having that second parallel pathway up to either enterprise systems or industrial IoT type of applications for non-control, where you don't worry as much about the latency sort of thing.
Yeah, I think it's best to use the right tool for the job. So mm-hmm. for real-time plant floor applications, they really want to use industrial field buses. It's optimized for that work. Yeah. And then things like OPC UA and MQTT has a lot of benefits for going up to a cloud or a SCADA system.
Yeah. Don't some of these more sophisticated networks suck up more power as well? Have you done anything to accommodate that demand?
Yeah, I haven't really seen, as far as the networking or communication platforms, I don't know that they're pulling a lot more, power from the devices. I think that both offer speed. I think things like OPC UA and MQTT have the benefit of maybe caching data. So if you have a disconnected connection to the cloud, right, that data still can get there. It just might go in a bigger batch.
Gotcha. That makes sense. In addition to device connectivity, there's another, range of decisions to be made when it comes to that topside connectivity. Are there differences in different methodologies for connecting from the IO modules up into the other systems?
Yeah, as we see that topside connectivity is becoming more important, we are enabling our IP67 distributed I/O with both the traditional field buses and OPC UA capability. So, like you mentioned, PLCs and HMI can utilize real-time information for their basic control functions via Ethernet-based field buses, and higher-level topside systems can exchange data via OPC UA at the same time. And in this way, the data can be routed at the same time to multiple systems, and the systems can use the protocols that they prefer.
Very, very capable little devices, that's for sure. With the decided move towards converged IT/OT architectures that feature Ethernet-based protocols, including IP addressable I/O modules, and the risks that can represent, how do you go about ensuring that those devices remain secure from cyber threats?
Yeah, that's definitely a good question. Network security is paramount today for plant floor devices. We recommend to our customers to use defense and depth methods to help them prevent cyber attacks. Mm-hmm. And a good start is really to zone the plant floor into networks in order to isolate systems. Mm-hmm. A second thing is to look at all your networking devices to see how you can reduce risks by reducing physical and network access. So, for example, using WAGO's lean managed switches in lieu of unmanaged switches enables users to turn off unused ports to help reduce unwanted access to a network. Lean managed switches can also enable users to set up rules that only allow approved devices to be used within a network. Mm-hmm. And in some cases, it's just not possible to control your networking, or network cables. So in those situations where it's not possible to secure the cable, we would recommend to encrypt the plant floor data using a technology like MACsec security.
Okay. Well, talk of MQTT and cloud connectivity for an IO module certainly makes sense from a perspective of emerging industrial IoT applications. But how do you make sure that those secondary communications don't bog down the primary business of real-time execution? I think you touched on that earlier, but maybe a little more detail on how that works.
Yeah, I would say as the trend for digitalization of the plant floor is in full swing, it would seem that sending real-time data to the cloud would be necessary. However, many users have found out that sending all of their plant floor data to the cloud is unproductive and it's really expensive. So we're seeing architectures are now being designed with edge of network devices that are on-premise to contextualize and summarize data before it is sent to the cloud. So these edge devices are running analytics locally to reduce latency as well as reducing data storage costs. And by only exchanging abridged data with the cloud applications, the amount of data transmitted and stored is greatly reduced. And the information that is sent to the cloud is enriched so that those Topside applications still function with a high rate of performance. And WAGO does offer a line of edge devices that are used as gateways between the real-time plant floor networks with the cloud applications.
So those edge gateways really take some of that load off of the I/O modules themselves or computational there, and then kind of our go-between on up to the cloud applications.
Yeah, definitely. I think they see these edge devices as being able to manage that real-time data and run analytics in real time, and then summarize that information, at slower intervals to send it up to the cloud.
All right, great. Well, it certainly seems that you've got a very flexible and very capable new line of IP67 products. Is there a particular URL you can refer to if people want more information on these products?
Yeah, you can probably just head to our website at wago.com, and you can see our new field devices right on our homepage.
All right, great. Well, thanks so much, Charlie, for sharing your perspective with us today. For those of you listening, thanks for tuning in. Thanks also to WAGO for sponsoring this episode. My name is Keith Larson, and you've been listening to a Control Amplified podcast. My guest today has been Charlie Norz of WAGO. If you've enjoyed this episode, you can subscribe at the iTunes Store and Google Podcasts. Plus, you can find the full archive of past episodes at controlglobal.com. Thanks again, Charlie. I really appreciate you joining me.
Yeah, thank you, Keith.
All right, signing off until next time.